The following animations help describe some of the strategies that students use at each of the 9 strategy stages of the Georgia Numeracy Project. Some specific examples are given to illustrate student thinking, but there are many more examples of strategies that students may use at each stage. At stage 0, students are unable to count a given number of objects because they lack knowledge of the count sequence and/or they lack the ability to match things in a one-to-one correspondence. In this example, the student lacks knowledge of the count sequence. At stage 1, students can count and form a set of objects up to 10, but they cannot solve simple problems involving joining and separating, like adding 4 plus 3. At stage 2, students are now able to join and separate sets of objects. Students rely on materials such as counters or even fingers to solve these problems, and they count all of the objects in both sets to find the answer. Stage 3 thinkers also count all of the objects to solve simple joining and separating problems. However, students at this stage are able to image visual patterns of the objects in their mind and count them. Students at stage 4 understand that the n number of the count sequence measures the whole set and can relate the addition or subtraction of objects to the forward and backward number sequences. This can be seen when students count on and count back to solve joining and separating problems. Students at stage 5 now realize that numbers are abstract units that can be treated simultaneously as wholes or can be partitioned and recombined. In this example, the student thinks about 9 plus 6 as 10 plus 6. Then, since 9 is 1 less than 10, takes 1 away from 16 to get 15. At stage 6, students have a wide range of part-whole strategies from which to choose to solve problems involving addition and subtraction. For example, for 63 minus 29, a student may choose to solve 63 minus 30 because it's easier to think about. Realizing that they took 1 too many away, they add it back to determine that 63 minus 29 is 34. Stage 7 students have developed and refined a range of strategies for solving multiplication and division problems. These strategies involve one or more of the numbers involved in the multiplication or division to be partitioned, manipulated, and recombined. In this example, the student thinks of 4 times 16 as an array and splits the array in half, making 2 equal smaller arrays of 4 times 8. The student then moves one of these smaller arrays on top of the other and creates an 8 by 8 array. And 8 times 8 is 64. Students at stage 8 are learning to select from a large repertoire of part-whole strategies to solve and estimate the answers to problems involving fractions, proportions, and ratios. These strategies are based on finding common factors and include strategies for the multiplication of decimals and the calculation of percentages. In this example, the student realizes that 2 6s make 12, but 3 6s is too much. Half of 6 or 3 more will get to 15 beanies. So 6 times 2.5 is 15. To find the number of balls of wool for 6 beanies, the student thinks about what number times 2.5 will give 10. 4 times 2 gives 8. 4 times 3 is too many, but 4 times 2.5 gives 10. So it takes 4 balls of wool to make 6 beanies.